I put on my shades? Okay, wait a second. Where are my shades? No shades! Okay. I know my shades. We'll have to put it on next time. I have my cool shades, my mental math glasses.
Your 3D glasses?
My 3D glasses, yeah, exactly. I look very cool. I am not cool at all, but I pretend. Okay, so let's look at the problem, okay? Now, this is the calculation for the change in kinetic energy. 1/2 m Vf squared minus Vi squared. 5 is the mass, correct? 5 is the mass. Jack, you with me? Excellent. 1 squared is going from 1 to 5. I'm sorry, going to 5 to 1. It's going from 5 meters per second to 1 meter per second. So it's going to be final minus initial. 1 squared minus 5 squared is 1 minus 25, which is negative 24 times 2.5. That's half of 5 is negative 60. Now, this is what you have to remember. Are you ready? Don't I do this a lot on the videos? I do this a lot, yeah. I do. See, there's a hole in my head, and that kind of like, it's like I'm an android, and I put my finger there because that helps to charge the battery a little bit.
Having a brain blast.
I'm blasting my brain, absolutely, Lana. Very good, very good. Okay, you've met people like me before, or androids like me.
Jimmy Neutron.
Jimmy Neutron, exactly. My third cousin, once removed. Okay, now, work equals change in kinetic energy. Did you get that? Patrice, don't look so excited, okay? She's a very exciting person. Don't let her fool you, okay? You all right? They call her Miss Excitement. She's very exciting. Okay. So what do we got? Work equals change in kinetic energy, right? You get that?
Yeah.
You get that? Okay, so if the kinetic energy equals negative 60 joules, then the work is going to equal negative 60 joules, correct? Yes, easy? Shema, shema. Okay, now, how do I get the force that slowed, that decelerated this box? Didn't I decelerate? Did I decelerate? What do you need in order to decelerate? You need a force, a friction, something, right? It's going to decelerate, right? You can apply that force either on brakes or a floor has friction. So what decelerated it? And what do you call that decelerating force? Don't you call it the
force of friction?
Force of friction, which is what? Think of, let's do memory theater. Picture an F. Can you picture an F? Close your eyes and picture an F. Yeah, go ahead, Erica. You can do it. Close your eyes and picture an F. Now picture it in a basketball net from the game on Friday, right? Picture an F in a basketball net. That's F net. Okay? You'll never forget that. No, I remember that. I'm 80 years old. F net, right? So F net is what's going to decelerate it. But it's also the friction. Because up here, because I can go, net force is what? If I had something accelerating this would be 0 minus force of friction, right? Correct?
Yes.
So it's going to be F net is force of friction. And I know from the equation, W equals Fd, solve for F, W over D, the force of friction is 60, negative 60 over 10, which is negative 6. So the force of friction is negative 6 newtons, right? And that's going to equal the F net. So the F net and the friction is negative 6 newtons. The change in kinetic energy and the work are negative 60 joules, correct? And a little deep purple, and let's see you later.